To start off with, my collaborators at Iowa State, Dr. Julia Calderon, who presented a lot of this data on Saturday, is a postdoc with Ken Stalder, and she was instrumental in collecting these data and doing a lot of the analyses that you see here. None of these projects would have taken place without the folks at Murphy Brown. They provided the commercial setting in which we were able to do these projects. Those folks include Gary Bradley, Christina Phillips, Ashley D. Decker, Bart Borg, and Joe Hahn. I'm going to show you some very recent mammary gland evaluations that were done by Russ Hovey and his student Caitlin Donovan. The folks at the Meat Animal Research Center were absolutely instrumental in collecting the data from the slaughterhouse. That includes the scientists that are in my unit. And then the Sow Lifetime Productivity Research Consortium, with the folks that are listed there, were all involved in developing the protocols that I'm gonna show to you. And then finally, Dr. Dean Boyd lent his considerable nutritional expertise in developing diets for the second trial, which actually worked quite well, but you'll see that when we get to it. Yeah. So just to start off then, these are the objectives of the first preliminary NPB-funded Gilt trial. The Sow Lifetime Productivity Working Group, which was a group of producers, wanted to have an experiment that would generate ad libitum-fed diets that would either slow growth or alter the body composition of developing gilts, specifically to try to increase the fat-to-lean ratio, so that, and then once those diets were developed, they would be used on a much larger trial on sow performance. At the same time that we were developing the diets and looking at the growth, we were also interested in looking at the dietary effects on age at puberty and reproductive tract development. And then finally, because we were looking at this in 1,200 gilts, it was an opportunity to begin to investigate some of the effects of litter of origin traits, which I'll talk a little bit about that as well. So the litter of origin data that were collected on these gilts included what's listed here. We took blood samples on day one for Immunocrit analysis, and that is a technique that I developed to provide an assessment of colostrum in piglets, whether a pig does or does not get sufficient colostrum. We also collected data on the parity of the dam, the number weaned, and then the day one weight of each piglet and the weaning weight of each piglet. Because we had day one weights and weaning weights, we were able to calculate the pre-weaning growth rate. And I'll show you that that does affect particularly age at puberty. This is the Gilt trial protocol. There were 6 diets. In a 2x3 factorial, there were 3 metabolizable energy and 2 SID lysine levels. Each of these diets was fed to 200 gilts, so the total experiment was 1,200 gilts. The diets were fed from day 100 of age to day 260 of age. Feed intake, growth, and body composition was monitored, was measured every 28 days in this protocol. Estrus detection and boar exposure began on day 160 and continued until day 260 when the animals went to slaughter. And then gilts were slaughtered, and reproductive tracts and mammary glands were collected from every gilt in the project. So these are the diets. So we started off with control levels of both a grower diet and a finisher diet, and these control levels were developed from an informal survey that Chris Hostetler made of a variety of producers. That control level was 1477 metabolizable energy per pound and 1% SID lysine in grower diets, and 1483 and 0.85 SID lysine in finisher diets. And then in this experiment, the metabolizable energy was diverged 10% in either direction, giving 90% and 110% of our control diets. And then the lysine was decreased by 15% in the low lysine versus the control diets. So that explains the 6 diets. Grower diets were given to animals up until they reach 200 pounds, and then finisher diets were given after that. This is the slaughter protocol at 260 days of age. The gilts went to slaughter. Reproductive tract was collected from each carcass. Ovary length and weight, uterine length, cycling and non-cycling for every uterus was collected. So this turned out to be very useful because we could tell the difference between animals that were prepubertal and those that were behaviorally anestrus. Number of CL on every cycling tract on which they were present was recorded. A mammary gland was collected from each carcass, and proximate analysis for fat and protein was made for each sample. And then every 10th sample, uterus, ovary, and mammary gland was collected for histological examination. Now, I'm not going to be able to present all of this data. I'm just going to present some of the highlights. So this shows the body weight. Remember, the body weights were collected starting at day 100 when the animals went on trial, and then every 28 days. And you can see here, these are all 6 diets, the plot of all 6 diets, and obviously from this there are no effects of the 6 diets on growth. There was also no effect of the 6 diets on loin-eye area. So by one measure, the diets were ineffective in altering the growth of the animals. Switching to back fat measurements, we did get a significant increase of the high metabolizable energy diets on back fat accretion in the developing gilts, but the increase was actually only about a 10% increase, and that translates into about 2 millimeters, which was at the end of the day was thought to be not sufficiently substantial to really try to use that in later experiments. Why didn't we get the changes in growth that we were expecting? Well, this slide right here shows you the whole story. The animals adjusted their average daily feed intake according to the metabolizable energy in the diets. So basically, the gilts ate around the diets. One interesting thing that you see here, though, is that they did not eat around the differences in the SID lysine in the diets. So the intake was pretty much all controlled by the metabolizable energy. So if you make your calculations according to the average daily metabolizable energy intake, the gilts all ate the same amount of metabolizable energy. If you then look at the daily lysine intake, they were all over the place. Now, they were all over the place, but the growth was absolutely identical, which we would interpret as indicating that even the low levels here were sufficiently high in lysine to allow for maximum growth. So remember that we started off here with a dietary regimen that was basically compiled from an informal survey of the industry, and then the low levels were 15% lower than that. So 15% lower than what people are using out in the industry is actually still optimal, and you still get maximum growth. So that's an interesting conclusion from this experiment. So we didn't get any changes in growth, and we didn't get any changes in age at puberty either in the 6 diets, as is shown in this slide. The age at puberty was all essentially the same, around 193 days of age, I believe. Because we slaughtered animals and were able to look at prepubertal, at how many animals were prepubertal, we were able to assess puberty failure at 260 days of age. Interestingly enough, that did appear to be affected by low levels of lysine compared to the control levels of lysine. But you can see here that just as George had indicated when he was up here, the level of puberty failure is in the 2 to 3% range under the control diet, and approximately doubled to perhaps 6% in the low lysine. So still, even though that's a significant increase or close to a significant increase, you still don't have a lot of animals that are failing to reach puberty. This is the first time I've shown this data, and this is some very recent data from Russ Hovey and his student Caitlin Donovan. Basically, what they did was they took the mammary gland histology sections that I sent to them, and they evaluated the mammary glands for the presence of these structures within the tissues. This TDLU is terminal duct lobular unit 1, 2, and 3, and basically what we need to know is that as you go from TDLU1 to TDLU3, it indicates increasing development of the mammary gland. So this is the preliminary histology results for this experiment, and basically what was found was there was no difference in the development of the glands in the high versus, or the control versus the low lysine group, but there did appear to be some changes in the development of the mammary gland in the high and medium compared to the low metabolizable energy. Even though these did not alter growth, they did appear to alter the development of the mammary gland. And essentially the low diets appear to delay or decrease the development of the gland. Now, what impact that has on later lactation, hopefully we may be able to look at that a little bit more in subsequent trials. I'm going to leave the dietary effects and just talk a little bit about litter of origin effects. This is some effects of the Immunocrit on growth. It is known that colostrum does affect later growth, and we were able to confirm that using the Immunocrit analysis, which provides a estimation of whether piglets do or do not get colostrum. So what you can see here is there was a difference in growth rates in gilts with high Immunocrit versus a zero Immunocrit. There was also a change in the back fat accretion within those same animals. So these kind of data and other data that we have that we've been able to generate at the Meat Animal Research Center suggests that if animals do not get colostrum, it does interfere with their later development, and probably does interfere with their later reproductive development. This is this is looking at the effect of pre-weaning growth rate on this axis and piglet birth weights on this axis against age at puberty on this axis, and it's a surface plot. What I have here are the individual LS means for age at puberty and the number of piglets, or the number of pigs that are present at each of these points on this graph. Basically, what this slide shows is that as you have poorer and poorer growth, pre-weaning growth rate during the pre-weaning period, you get an increase in age at puberty, subsequent age at puberty, and this becomes even worse for piglets that have a high birth weight. So the combination of large birth weights and poor pre-weaning growth potentially predispose gilts to having a longer age at puberty. That's the bottom line from these results. So what did we learn from the first experiment? As I said before, to the extent that metabolizable energy and lysine levels in the diet are economically valuable, the industry at the time appeared to be feeding gilts too high a concentration of both. The metabolizable energy was too high because gilts will eat around that, and the lysine levels were too high because reducing it by 15% had no effect on growth rates. Back fat can be manipulated using metabolizable energy by increasing it 10%, but the amount that we achieved in the trial was very limited. Only a 10% increase occurred, and this was thought to be not substantial enough to go forward. Efforts to improve colostrum management and pre-weaning growth of piglets will likely help puberty attainment. Low lysine levels appeared to increase puberty failure, but this increase was from 3% to 6%, so still quite low. And then low metabolizable energy appeared to delay mammary gland development in gilts at 260 days of age. The consequences of that are not really known, but hopefully we can explore that in later experiments. So the thing we didn't get to answer, though, is we did not develop diets that reduce growth and or alter body composition. So the cell lifetime productivity working group basically wanted us to do another experiment with different diets. In the subsequent experiment, we did not take any litter of origin data. And Dr. Jean Boyd was instrumental in developing diets for the second trial. We started off with grower diets that sort of began where we left off in the previous experiment, and then decreased the SID levels even further than what we had in the first trial. And because of the results that we had in the first trial, the metabolizable energy was held constant. This shows the levels for SID lysine in grower diets. This shows the level of SID lysine in the finisher diets. The other thing that we added to this trial was an increase in MIDS and corn germ to try to prevent gilts from eating around the diet if they were going to do that. So this is our new protocol. Gilts were placed on the diets once again from day 100 of age, and they were fed until 220 days of age, because now these gilts were going to go into the Murphy-Brown breeding system rather than go to slaughter. Weights, back fat, and loin depth were measured every 28 days, just like we did the last time. Bore stimulation began at 160 days, just like the last time. Different from the last time, all gilts were weighed, and flank-to-flank measures were taken at estrus. This turns out to give us some interesting data, which I'll show you in a minute. Rather than go to slaughter, the gilts were removed from the trial and went to the breed line at the Murphy-Brown farm approximately 10 days before the second estrus. Because we weren't slaughtering animals and did not have the opportunity to tell whether they were or were not prepubertal, we took blood samples at 210 and 220 days of age for all those animals that had not experienced an HNS. And we used those to measure progesterone to tell whether animals were or were not cycling. And then gilts with no HNS by 220 days of age received PG600 and were monitored for estrus response within a week after that injection. Now, I have to tell you that this experiment was unfortunately impacted by a PED outbreak just as it was beginning to get started. There was a PED outbreak at the research farm on September 6th, 2014, which was coincident with the beginning of boar exposure for the first group of gilts. Boar exposure for that group was delayed 1 week to allow the gilts to recover, but the remainder of the gilts stayed on schedule. So they recovered okay, but it's likely that the PED outbreak did impact the data to a fair extent, and that's going to become clear in a minute. This is the body weight growth results that came from this experiment, and now you can see that we were actually successful. These diets were pretty much entirely successful in meeting the objectives, in that the high, medium, and low diets were effective in changing the growth rate of these gilts. So we were successful in developing diets that at least altered body weight. Interestingly enough, they did not alter the fat-to-lean ratios. So changes in the loin-eye areas and in fat essentially mirrored the changes in body weight growth, and there was no difference in the fat-to-lean ratios among the gilts. This is the age of puberty results from the second trial. The low treatment was significantly had a significantly later age at puberty compared to the medium and high treated gilts, which were not different from each other. But interestingly enough, if you look at the total number of gilts that actually came into heat by 220 days of age, that was not statistically significantly different. However, the percent of gilts that actually reached estrus within that 220-day period was very low, and this is likely caused by PED. So the number of gilts that reached puberty naturally in this experiment was in the 1/3 range, 30%. The number of this slide shows the number of gilts that were injected and then responded to PG600, and you can see here that 80 to 90% of those gilts did respond to PG600. So we interpret that to mean that most of these gilts were in fact not pubertal. They were not behaviorally anestrous, and the progesterone analysis actually confirmed that most of the gilts that did not have HNS were in fact not cycling versus behaviorally anestrous. And then finally, I just want to explore this slide here, which has a number of different concepts that I'd kind of like to talk about a little bit. This is a relationship between the flank-to-flank measures that were taken at estrus and the weight measures that were taken at estrus. And there's a number of things that this illustrates along the same lines of what George was describing. The first thing is, if you look at the 36-inch threshold, which was being used to estimate whether gilts met the 300-pound average weight before breeding, we can see that was approximately right. It corresponds to all the gilts being above the 135 kilogram threshold. But what you can also see is that many of the gilts are much, much heavier than that. The average for 36 inches is actually 160 kilograms. And what that means is if you're using 36-inch flank-to-flank threshold as your breeding target, half the animals would be above the threshold for breeding that George was describing as not particularly helpful in terms of whether they would stay in the herd. The other thing you can see here is these two lines, these were taken at estrus, so these gilts are going to have another 20 days before they are actually eligible to be bred, so we kind of have to back up that 135 to 160 kilogram threshold, which I've done with these two blue lines. And so at estrus, the threshold should be about 115 to 140 if gilts are growing at a kilogram per day, which these gilts were. So if they were growing at a kilogram per day and you have another 20 days, then weights at estrus should be between 115 and 140 kilograms. And you can see here, one of the useful things that comes from this is if you plot the high, medium, and low lysine, you can see that the high lysine gilts, 2/3 of them were above the threshold of 140 kilograms, which would make them too heavy when they actually came into heat to be bred the second time. But the medium group was a little lower than that, and the low group was lower still. And so the low group would accomplish the objective of getting at least a better proportion of gilts to hit that 135 to 160 kilogram target that George was talking about. So what did we learn from the second experiment? Lysine levels can be used to reduce growth in ad libitum-fed gilts if metabolizable energy levels are held constant. The change in growth did not affect fat-to-lean ratio. Fat differences were still not very great. It appears to be very difficult to alter fat with ad libitum diet modifications. Low lysine increased age at puberty, but did not affect the percent pubertal by 220 days of age, with the caveat that only 1/3 of these gilts reached puberty in this experiment, likely because of PEDV. So to summarize the results of both these trials, suitable diets have now been developed for a larger trial to look at slower gilt growth and the effects of retention of those gilts in the herd, and that trial will begin in January using the diets that were developed in the second trial. We confirmed effects of colostrum and pre-weaning growth. Confirmed effects of colostrum and pre-weaning growth on subsequent performance This is related to experiments that I have done at the Meat Animal Research Center. And mammary gland function is an objective of the upcoming trial, so more will be learned regarding mammary gland function. We have shown that the diets do appear to have an influence on mammary gland development in the gilts. We'll explore that further in the coming trial.